Okay, folks, welcome back. We're going to work on section 8.3 today, matrix arithmetic. The worksheet you see here you should have picked up in class. Got a couple definitions to start. Matrix is a rectangular array of real numbers. That's something we talked about in section 8.2, but we've been using all the way back to section 8.1. And here's a note. Matrix addition, subtraction, and multiplication by a scalar means multiplication by a scalar is just by a number, not by a variable. So addition, subtraction, multiplication by a scalar act pretty much like you would expect them. So we're going to just jump right into some examples. The only other thing I want to mention before the examples is when we talk about a matrix dimension, we talk about rows by columns. So this example matrix here, A, has m rows and n columns. So the dimension of that matrix, this matrix dimension, is equal to m by n. M rows, n columns. Okay, let's move down to these examples. I've given you three different matrices, a 2 by 2, another 2 by 2, and then a 2 by 3. And I ask you to perform the operations that are listed here. So for 1A, we're going to add the two matrices. As I mentioned before, matrix addition acts pretty much like you would expect it to. We are going to add the same position from each matrix. So I'm going to do -5 plus 2 for the upper left, for the first row, first column. For the first row, second column, I'm going to do 3 plus -4. For the second row, first column, I'm going to do 2 plus -1. And for the second row, second column, I'm going to do 6 plus 3. And the resulting matrix is -5 plus 2, which is -3, 3 minus 4, which is -1, 2 minus 1, which is 1, 6 plus 3, which is 9. Pretty straightforward. When we go ahead and do matrix subtraction, I'll go here and look at example B. Same idea. We're going to do -5 minus 2, 3 minus -4. Notice how I switched the sign there to addition. 2 minus -1, 6 minus 3. The resulting matrix is going to be -7, 7, 3, 3. So it looks very different than the previous one, but that is the correct operation. Okay, let's go ahead and look at B minus A now. So we're going to switch the order of the subtraction. B minus A is going to look like this. 2 minus -5, -4 minus 3, -1 minus 2, and then 3 minus 6. And I'm going to get the following matrix. 7, -7, -1 minus 2 is -3, 3 minus 6 is -3. Well, that's kind of interesting. All the numbers look the same as they did up here, but the signs are switched. That shouldn't surprise you too much. When we reverse the order of subtraction, we get the opposite of the previous value. Okay, so now we'll get into just a little more complexity here. We're going to do A minus 2 times B. So I have to multiply the matrix B by 2 before I do the subtraction. So I'm going to start in the upper left with -5, and then I have to do minus 2 times 2. In the upper right, I have 3 minus 2 times -4. Lower left, I have 2 minus 2 times -1. And then in the lower right, I have 6 minus 2 times 3. When you complete that multiplication, addition, and subtraction, you end up with the matrix here, this 2 by 2 matrix. And again, this is pretty much like you would expect it to work. Let's look at example E now. We have A plus C. So matrix A is this 2 by 2 matrix here, and matrix C is this 2 by 3 matrix here. Well, this presents a problem for us, because I can certainly see how maybe I would do -5 plus 2 for row 1, column 1, and 3 plus 4 for row 1, column 2. But then what do I do for column 3? Well, the answer is nothing, because this is undefined. Okay, the matrices must have the same dimensions if we're going to do addition or subtraction. Last time I checked, that's not how you spell same. Okay. All right, we'll move on to example F now. Example F is just 5, the scalar multiple of 5 times the matrix C. In order to do that, I'm just going to do 5 times every element in this matrix. And again, this acts pretty much like you would expect it to. I'm going to get 10, 5 times 2, 5 times 4 is 20, -15, 15, 5, and 35. Okay, now we're going to move into example 2 and 3, which involve equations that have matrix equations. Another way to say that is equations that have matrices in them. So for example 2, I have 3 times matrix A plus this 2 by 2 equals this 2 by 2 plus this 2 by 2. So my approach to this is going to be just like it is for any time I'm solving an equation for some unknown. I'm going to try to isolate that unknown. My first step is going to be to simplify the right-hand side. So by simplifying the right-hand side, I'm going to add those two matrices. That's going to give me 5 here, 15, 13, and 17. Okay, the next step to get the 3 times A, 3 times matrix A all by itself, I'm going to subtract from both sides of this equation that matrix 2, 9, 4, 5. I'm going to subtract that 2 by 2 from both sides, and that's going to give me 3A equals, so I'm going to do 5 minus 2, which is 3, 15 minus 9, which is 6, 13 minus 4, which is 9, 17 minus 5, which is 12. Alright, so what do I do now to get A all by itself? Well, I haven't talked about matrix division. Normally you would think of this as dividing both sides by 3. But we can achieve the same thing by, if we multiply both sides by 1/3. If I multiply the left-hand side by 1/3, I get A. If I multiply the right-hand side by 1/3, I'm going to get 1, 2, 3, 4. Isn't that convenient? So instead of thinking of this as division by 3, we multiplied by a scalar 1/3. Okay, so the example 3, it's a little bit more complicated than the one we just did, but the same ideas. First thing I'm going to do is look at this left-hand side. I have 3b minus this matrix, and then I have to distribute that negative side minus 5b. So I can simplify this a little bit by saying that 3b minus 5b is negative 2b. And then I'm going to subtract that 2 by 2 matrix. And that's going to equal, well, I'll leave this one alone for just a second. But I will simplify this scalar multiple of 1/3 times each of the elements in this matrix. 1/3 of 9 is 3, 1/3 of 12 is 4, 1/3 of negative 3 is negative 1, and 1/3 of 39 is 13. Now with the right-hand side of this matrix, I can combine these two. I can add these two, and this is what I'll get. Pause it on there for a second, folks. When I do that simplification, I now get negative 2b minus this 2 by 2 matrix equals this 2 by 2 matrix. Next thing I'm going to do is add this matrix to both sides so that it'll disappear from the left and then be added to the one on the right. That's going to give me negative 2b equals negative 1 plus 2 is 1. 6 plus negative 1 is 5. 5 plus 3 is 8. 11 plus 5 is 16. The next thing I'll do is to solve for b by multiplying both sides by negative 1/2. Negative 1/2 by 1 is negative 1/2. Negative 1/2 times 5 is negative 5/2. Negative 1/2 times 8 is negative 4. And negative 1/2 times 16 is negative 8. And there's our final answer. I'm going to go ahead, folks. I'm going to write in some of these steps for you in case you want to refer back to them to know how each of these, how we got from this to this to this to this. All right, folks, I've filled in all the steps for this example problem 3 for how we started with this equation up here to get down to b equals this 2 by 2 matrix. I'm going to go ahead and end this video. For page 2 of the notes, look for part 2 of this video.